There are two special right triangles that are the underlying basis of a lot of the work that we do in trigonometry. And that's the 45-45-90 triangle and the 30-60-90 triangle. So they're both right triangles that have these particular measures, two 45-degree angles or a 30-degree and a 60-degree angle to go along with the 90-degree angle. And it just so happens that their sides follow a specific pattern that we can take advantage of eventually to apply to our trigonometric ratios. So in the case of a 45-45-90 triangle, from our geometry days, we know that this is going to be an isosceles triangle, meaning that if we have these two angles that are congruent, then that means the sides across from them are going to be congruent. So that's why both of those are labeled with x's. So if one is 5, the other would be 5. If one was 10, the other would be 10. And then it works out that the hypotenuse in a 45-45-90 triangle is going to be whatever the length of that leg is times the square root of 2. So I can get to and from the legs by multiplying by root 2 to get to the hypotenuse, or if I'm going the opposite direction, if I know the hypotenuse, I can divide by root 2 to figure out what the leg is. In the case of the 30-60-90 triangle, of course, it's not an isosceles triangle, so we don't have two sides that are the same, but we still have a pattern that we can take advantage of. And so it all starts with the short side of the triangle, which is the one that is across from the 30-degree angle, wherever that is. And so it turns out that to get from that short side to the hypotenuse, we can multiply by 2. So whatever that short side is, the hypotenuse is going to be twice as long. And to get to the other leg, the longer leg, the side that's across from the 60-degree angle, we can take that short leg and multiply by root 3. And of course, if we're going the opposite direction, if we know the long leg, we can divide by root 3 to get the short leg. If we know the hypotenuse, we can divide by 2 to get the short leg. But it all pivots off of knowing that short leg. And so what this means for us is if we only know one of the three sides, we can figure out the other two. Under most circumstances, we need to know two of the sides so that we can use the Pythagorean theorem to figure out what the third missing side of a right triangle is. But for these two triangles, following these two patterns, we can find both missing sides having been given only one. So in the first example here, we can see that we have a 45-45-90 triangle. So we're operating with this one right here. We can see that we're given one of the legs. It's not the side across from the 90-degree angle, so it's one of the legs. So that means I know that x is going to equal 12 as well. I know that both of these angles are 45 degrees. That means both of the sides across from those are going to be the same length. So that's going to be 12. And then to get from the leg to the hypotenuse, I'm going to multiply by root 2. So 12 times root 2 means that this side is just going to be 12 root 2. For the next example, we can see that we have a 30-60-90 triangle. So we know if this angle is 30 degrees, then the other one has to be 60 since we've got a right angle there. So that means we're operating with this one right here. And so the length that we know is the hypotenuse. So we have to work back to get the short leg. And so if you recall, the hypotenuse is twice as long as the short leg being the one across from the 30-degree angle. So that means in this case, to figure out what x equals, I'm going to divide by 2. So if I take 18 root 3 and divide that by 2, I'm just going to reduce my fraction here. So I end up with 9 root 3 is my answer for x. And then to get from the short leg to the long leg, which is what we're doing next, we're multiplying by root 3. So I'm going to multiply by root 3. So I'm going to take that same 9 root 3 answer and multiply it by root 3. Well, root 3 times root 3 is just 3. So we've got 9 times 3, which is 27. So that means our value for y is 27. So we've got x is 9 root 3, y is 27. The last one of the bunch, we might be baited into seeing this root 3 here and think, root 3 is a 30, 60, 90 triangle, but if we note the measures of the angles, it's clearly a 45, 45, 90 triangle. So if that is one of the legs right here, 15 root 3, that means the other leg, in this case x, is also going to be 15 root 3. We have an isosceles triangle, and so then to get from the legs to the hypotenuse, we again remind ourselves we're going to be multiplying by root 2. So I'm going to take this answer and multiply by root 2 to figure out what the hypotenuse is. So I've got 15 root 3 times root 2. So if I multiply those, I'm going to get 15 times the square root of 6. So there's my answer for y. 15 root 6 with x being 15 root 3.